Hi everyone. So today's going to be our last lesson from chapter 7 on similarity in triangles. And I'm sorry I'm not there. I haven't been there this week because this flu is not so fun. But you should be on page 18 in your notes, and it should at the top say the triangle proportionality theorem. And one thing, it may say section 7.5, but it should say section 7.6 because that's what section we are in our book. But first we're going to look at this really cool theorem called the triangle proportionality theorem. I also like to call it the side splitter theorem. Okay? And the reason I call it the side splitter theorem is because it splits the sides. So let's write this down. If a line parallel to one side of a triangle intersects the other two sides, it divides those sides proportionally. It divides those sides proportionally. Basically, if you look at the figure that I gave you, and if we take a pen, hopefully a colored pen, and we give the length TR, we call it X, and QT, we call it Y. And then RU, we say it's a lowercase r, and then SU, we give it S. If these two lines are parallel here, TU and QS, if they're parallel in the triangle, instead of separating the triangles like we have been, you can use this triangle proportionality theorem. And the proportions that would be true would be that X over Y equals R over S. So we're basically cutting the sides proportionally. We're splitting the sides proportionally. So X over Y equals R over S. All right, so now that actual theorem can be extended a little bit further. And I call it the corollary, and our book calls it the corollary to the side splitter theorem. Now you may notice though that the picture I gave you is not triangles. So this theorem's slightly different, but it basically says, let me change the size here. If three lines parallel intersect two transversals, then it divides them proportionally. Okay, so let's look at this. We've got three parallel lines, one right here, one right here, one right here, and one right here, and they're intersecting two transversals, then that's telling me that it's dividing the segments or the lines proportionally. So if I call this segment X right here, and I call this right here segment Y, and then I call up here R, and I call this segment VX, if I call that S, then that same proportion we just saw works. So X over Y equals R over S. X over Y equals R over S. And I am going to be showing you how to use these in a few minutes. All right, one more. This one's kind of funky. The triangle bisector theorem. It even sounds funny. Okay, so the triangle bisector theorem says that if a ray, remember that ray, bisects an angle of a triangle, then it divides the opposite sides proportionally to the other two sides. So that one's kind of hard in a lot of words. Write it down, and then I'm going to explain what we mean. Okay. So if a ray bisects an angle of a triangle, then it divides the opposite sides. It divides the opposite sides proportionally to the other two sides. All right. So let's label some sides here. X would be AD, and Y would be DB, and then R and S. So here's the ray bisecting the angle. That means that it's dividing the sides proportionally. So X over Y equals r over s. So this over this equals this over this. All right, let's put all those to work. So here we go. Finding the length of EC. So I notice I have a triangle, and I notice the parallel lines. They have to be parallel for this to work. And I'm trying to find EC, so I'm going to give it a length of x. Cool. All ready to go now. I can use the triangle proportionality theorem to write a proportion. So 4 over 8 equals x over 12. All right, I simplify. 1/2. And then I can cross multiply. So 12 equals 2x, and x equals 6. That's the triangle proportionality theorem. A little harder is when I give you kind of funky pieces. I'm trying to find the length of yx. So I'm going to put a little x there. But I notice I'm given 3 here, but I'm given the whole length, uw. So I do have to subtract, do 18 minus 3 to get this length of 15. Because I have to use the sides of the triangle, not the whole side of the triangle. So my proportion then would be 15 over 3 equals 16 over x. Now, I do want you to know you could write that as well if you wanted to as 3 over 15 equals x over 16. That works as well, okay? So 1/5, I'm going to simplify, and then I cross multiply, and I get 5x equals 16, and then I'm going to divide both sides by 5. So x equals 3 1/5, okay? Or you could leave it as 16/5. I want you guys to get used to seeing those fractions as answers because they are answers to questions. All right, let's try that corollary. Notice we've got 3 parallel lines. I know they're parallel because these angles are all congruent and they're corresponding angles, so that tells me these lines are parallel, which means that if I'm trying to find TU, that those lines are cutting the transversals proportionally. So I can write a proportion. 9 over 15 equals 11 over x. 9 over 15 equals 11 over x. Always want to simplify. So 3 goes into 9 3 times, 3 goes into 15 5 times. And now I'm ready to cross multiply or cross product. So 3x equals 55. Then divide both sides by 3. And therefore I get x equals 55/3. Okay, you try the next one. So I gave you your 3 parallel lines, and I want you to find x. Press pause and try it. All right, so you pressed pause, you're back. Your proportion should have been 6 over 9 equals x over 8. Now, you could have written that proportion several different ways. Simplify to 2/3. And then cross multiply 3x equals 16. So x equals either 16/3 or 5 1/3. All right, so that's how those two theorems work. Let's try the last one. Okay, so example 5. We can see that we've got an angle being bisected right here. So that tells me that this is a ray, even though it stops, okay? But this one's trickier, okay, because I actually have to take that 14 and break it into parts because the theorem says it divides the sides proportionally to each other. So I'm going to call this x, and if that's x, then this side would be 14 minus x, okay? So now I'm ready to actually write my proportion. So I can do x over 14 minus x equals 9 over 15. All right, I simplify. So 9 and 15 is going to simplify to 3/5. And now I'm ready to cross multiply. So I'll get 5x equals, all right, make sure that I do 3 times the whole quantity, 14 minus x. So 5x equals 42 minus 3x. I'm going to add 3x to both sides. So 8x equals 42, and I'm going to divide by 8. All right, so then x equals, let's see, 42 divided by 8, I believe then is 5 2/8. which then is 5 1/4. All right, let's try the next one. You try it, actually. Why don't you press pause and try it, and then turn back on and see how you did. Okay, so you're back. So hopefully you noticed that the whole length, ln, was 15, so you had to break it up into x and 15 minus x. Now, you don't always have to do that. You have to really pay close attention to what they give you. In this case, they gave me the whole length, so I had to break it into parts. So then I wrote my proportion, x over 15 minus x equals 3 over 17. Okay, 3 over 17 does not simplify, so I've just got to jump to cross multiplying. So I get 17x equals 3 times 15 minus x. Now I'm putting that in parentheses so I don't forget to distribute. So 17x equals 45 minus 3x. I'm going to add 3x to both sides. And so I get here, I'm going to come up here. 20x equals 45. And then divide by 20 on both sides. So x equals, let's see, 9/4. 5 goes into 45, 9, and 5 goes into 24 times. So 9/4 or 2 1/4. So either one of those I'd accept. All right, let's try a couple more. Example 7. Find the value of x. Okay, so if I see the whole length is 20, now they've given it a name of x, then this would have to be 20 minus x. Okay, all right, so 20 minus x over x equals 11 over 14. Now just remember, be careful. If you take the 20 minus x on the top over here, then that means you have to pull the 11 on the top on the other side. It has to be in the same like correspondence. All right, so I see that 11 over 14 does not simplify, so I got some big numbers here. I got to cross multiply. So 14 times 20 minus x equals 11x. All right, distribute. That gives me 280. I think that's 280. You can check my work. Minus 14x equals 11x. All right, now I'm going to add 14x to both sides. So I get 280 equals 25x. And then I divide both sides by 25. And then I simplify that, and it looks like 25 goes into 280. It's 11 1/5. All right, guys, you try example 8 and press pause, try it, and then come back and we'll check your answer, okay? All right, you're back. So you pressed pause, you tried it, you saw that the angle was being bisected, so you could use the triangle bisector theorem. Okay, and you wrote a proportion. I didn't need to write x and 15 minus x because I gave you the sides being split. So 3 over 4 equals 7 over x. Cross multiplied because it's already in its simplest form, and you get 3x equals 28. Divide by 3. So x equals 28/3 or 9 1/3. All right. Hopefully that was helpful. If you feel like you still aren't quite sure, you can take this time right now to go back and rewatch. But otherwise, you're going to move on to your textbook, page 272 to 273, numbers 1 through 11 all, and 20 to 24 all. Now, I know that some of you may not have your book, so I copied the pages to the book and I posted them under the topics page so that you have the textbook pages for this. So you can open up the textbook right on your computer. Make sure you draw all diagrams, and I will be going over any questions when I get back on Friday. Have a great day, guys.